In this video, we'll add a basic weapon to the FPS game, which will allow the player to shoot and also to reload. We'll begin by creating the graphics for the weapon, and then we'll add a script that allows for aiming and shooting. First, let's make the graphics. This will be a cylinder that's attached to the camera, so that when the camera moves, the cylinder will move with it, making it look like it's being held by the player. Inside the FPS controller prefab, there's an element called the first-person character. This is where the camera is located. Let's make an empty object by going Game Object, Create Empty Child, and we'll name it Weapon. Because the position of this is 0, 0, 0, it's positioned at the same point as the camera. Next, we'll create another child object that will be the actual graphics. We'll do this by going to the Game Object menu, choosing 3D, Cylinder. We'll make sure the cylinder is a child of the weapon. Next, we'll remove the capsule collider that it comes with, because we don't need it. This will be purely for graphical display. We won't be using it for any kind of physical collision detection. So we'll click on the little gear icon next to the capsule collider, and we'll choose Remove Component. Next, we'll position this so that it's in the right place for the camera. I'll set this to 0.4, negative 0.4, 0.8. Let's zoom in. You can see how this is positioned just to the right and ahead of the camera. Next, we'll rotate this so that it's facing the right direction by changing the rotation on the x-axis to 90. Finally, we'll also scale this appropriately because right now it's a little too big. So we'll change its scale to 0.25, that's a quarter of its width, 0.8 on the y-axis, and 0.25 on the z-axis. Now, it's an appropriately shaped tube. Looking at this in the game view, you can see that this is now approximately where you'd be holding something that was in your right hand. Let's play the game and see how it looks. So as we move the camera around, the weapon moves with us. There is a bit of a problem though. Looking down at the ground, we can see that the weapon is casting a shadow, even though the rest of the player is not. We can see why this is by looking at the character. Notice that there is nothing visible of the character. The character can't see themselves. The weapon is the only visible thing in the scene. Let's fix this by turning off shadows on the weapon. We'll click on the cylinder. We'll change Cast Shadows from On to Off. Now, when we play the game, our shadow is gone. Notice that it still receives shadows, however. Next, we'll add a material for our weapon. We'll create a dark green, shiny metallic material for the weapon. Let's go into our Materials folder, right-click, and create a new material. We'll name it Weapon. We'll change the albedo from white to a dark green. So we'll go to the green hue and then something like around there. I'll now apply this weapon material to the weapon by dragging it onto the object. Right now, though, it looks more plastic than metal. Metal is significantly shinier than this. If we increase the smoothness property to 0.9, you'll notice that the whole thing becomes significantly shinier. Let's see how it looks in game. Much better. We'll now write some code that actually implements the behavior of our weapon. Specifically, what it will do is every time the user presses the fire button, it will cast a ray out into the scene to see what it was hitting. We'll now use information about what was hit to affect things like visual effects and also to apply damage to things that can take damage, such as the enemy, which will be appearing in other videos. To keep our things organized, we'll create a folder for our scripts. We'll go to the Assets folder, we'll right-click, Create, Folder. We'll name the new folder Scripts. Let's add a new C# script to this folder. We'll open it, right-click, Create, C# script. We'll name this Basic Weapon. We'll double-click to open it, and here we are. We'll be making use of the cross-platform input system that comes as part of the Unity Standard Assets package. To make use of this, we'll add a using declaration at the top by saying using Unity Standard Assets dot cross-platform input. We want our weapon to have a fixed amount of ammunition in the clip. When the ammunition in the clip is empty, they will not fire, and instead they have to be reloaded. We'll make this happen automatically when you run out of ammo. Additionally, we want the script to display the amount of ammo remaining in the clip in the field that we set up in the UI. With that in mind, let's begin adding properties to our script. So we'll say public int max clip size. This will be the maximum amount of ammunition that can be held in the clip. And we'll default that to 8. We'll also create a private variable, an integer also, called ammo remaining. We'll default this to 0. We'll also create a variable that controls the maximum range of the weapon. Any further than this range, and hits will not register. Float max range will be the name of it, and we'll default it to 100. Next, we'll add a variable that controls whether or not this weapon is player controlled. This is because we want to use this weapon script on the enemy as well. And if the weapon is on the enemy, then we don't want it to respond to input. If we didn't do this, then every weapon in the scene would fire when the player clicked the fire button. And that would not work very well at all. So we'll add a variable, public bool player controlled equals true. We'll default it to true. Additionally, we need to have a reference to the label that will display the amount of ammo remaining in the gun. Public unityengine.ui.text ammo remaining label. As an alternative to saying unityengine.ui.text, we could instead use unityengine.ui and then remove the reference there. So we'd simply say public text. We're now done setting up the variables. Let's write the start function, which is run on the very first frame that the script exists. In start, we'll begin by saying that the amount of ammo remaining is equal to the maximum clip size, that is, the weapon begins fully loaded. Next, we'll create a function called updateUI, which will update the user interface to show the amount of ammunition remaining. We'll say void updateUI. In this function, we'll check to see whether the ammo remaining label is set to something useful. So if ammo remaining label is not null, then we'll take the amount of ammo remaining, convert it to a string, and display it in the text. Ammo remaining label dot text equals ammo remaining dot toString. Next, we'll write the function that fires a shot. We'll call it fire, and in this function, we'll reduce ammo remaining by 1, and then call updateUI. Ammo remaining minus equals 1. Next, we call updateUI. When the weapon is reloaded, we set ammo remaining back up to the maximum clip size, and then also refresh the display of the ammo count. So let's write a new function, void reload. Here we'll say ammo remaining equals max clip size, and again call updateUI. Finally, we'll write the update function. This is called once every frame. In this function, we'll first of all check to see if this is a player-controlled weapon. If it's not, we'll stop right away, because non-player controlled weapons should not respond to input. Next, we'll check to see whether or not the fire button has just been pressed. If it has, we'll either fire a round if we have ammo remaining, or we'll reload and not fire. So, if player controlled is false, then return. We'll stop right away. Otherwise, if cross-platform input manager dot get button down fire 1, if that's true, then the button was just pressed on this frame. This will not be true on the second frame after the button started being held down. So if we click and hold, which is likely, no matter how fast you click, you're unlikely to be clicking for just a single frame. So doing this means that we're able to detect the moment of pressing fire. So in here, we'll check to see if we have ammo or not. If ammo remaining is greater than 0, then we should fire by calling fire. Otherwise, we'll call reload. We're now done writing our basic weapon script. We'll pause here for now, and we'll come back in the next video and set it up in our scene.